Hello, this is checkpoint 2.5 from section 2.1. Here they want us to find the region depicted by this figure and the area, finding the area with respect to, by integrating with respect to y. So if we look at it along the y-axis, we can kind of see that we have a function. This function here is going to be greater than the other function down here, and I'm calling them functions because right now they're expressed as functions of x, so we need to rewrite these functions as functions of y. And the best way to think about doing that is to say this function over here is y is equal to the square root of x. So generally we want to solve for this, so we're going to say x is equal to, if we square both sides, x is equal to y squared. So this function here is y squared, and it's going to be the function for the lower integral, lower part of the integral. So that will be the second function. Now the first function is up here, which is right now written as y is equal to 3/2 minus x over 2. And so what we want to do is solve for x. Let's multiply both sides by 2, so it'll be 2y, and then we'll subtract the 3, so that's 2y minus 3, and then we have to switch signs to get x by itself. So it'll be, you get x by itself, this is y minus 3, switch the signs, it'll be 3 minus, not y, but 2y. So these are our two functions. We can call it f1 and g1 of y. But now we have functions of y. And yeah, so we'll call it maybe g1 of y, which is going to be equal to 3 minus 2y. And the first one that we found we'll call f1 of y, which is y squared. And we can make our notes to say, hey, g1 is bigger than f1. So g1 of y is bigger than f1 of y. That's because g1 is on the right side of f1, if we're looking at it. Or you can tilt your head to the right, and then you can see which one's bigger. And this is happening on the interval. We need y intervals, and we can use the bracket integral, but let's use this less than or equal to. So it looks like it's going to go from y is equal to 0, and then wherever these two intersect, so we probably should equal, let's set them equal to each other. We can set these equal to each other, and we're going to get, you can kind of see that it's equal to 1 according to the drawing, but if we set these two equal to each other, we would say y2 is equal to 3 minus 2y. This is a quadratic, so we probably want to bring everything on one side. Y squared plus 2y minus 3 equal to 0, and factor. And we're going to get 3 and 1. So we'll put 3 and 1, and one of them is positive, one of them is, so the one with a 3 is the one that's positive, this is negative. So they looks like they'll intersect at -3, y is equal to -3, which is not in the picture because that's below the x-axis. So it looks like this thing's going to loop back and intersect later. But they do intersect at y is equal to 1, which is what we were looking for. And so that's going to be our integral setup. All right, so let us set up our integral. The region area is going to be equal to the integral from 0 to 1 of, remember that g is the first function, so it's 3 minus 2y. And then we have the y squared function, dy. So that's our integral. Just three pieces, 3 terms to our integral, so we could just go ahead and work that out. We have 3y minus, this is a y squared over 2, we'll cancel the 2, and then this is a 1/3 y cubed. We're going to integrate this from, or evaluate from 0 to 1. And when we put 1 in there, we know that we're going to get nothing. Because when we put 0 in here, we'll get 0, so we'll just put 1. So it's 3 minus 1 minus 1/3. And then put a minus 0 there if we want. So this is going to be 2 minus 1/3, and 6 minus 1 is 5. 5. So this would be 5/3. And then that's it. All right. I hope that works, and good luck.